So now we got to talk about capacitors in parallel and series, much in the same way that we talked about resistors in parallel and series. So what I have here is I have two capacitors, and if you can see it right here, they're in parallel. Okay, so I have a voltage that's creating this this potential difference. It's creating electrostatic pressure, and both of these capacitors are experiencing that voltage, that electrostatic pressure. So what I need to do is I need to be able to calculate that total capacitance, realizing that both of them are experiencing the exact same electrostatic pressure. So what I'm going to do is I'm going to say that the total charge that's stored on those capacitors is equal to the charge of 1 plus the charge of 2. So the amount of charge that's stored here and the amount of charge that's stored here is the total amount of charge stored. Okay? That seems kind of logical, and, in a logical sort of way, I guess. So from there, I'm going to take it one step further. I know that when I'm talking about total charge, that's equal to the capacitance times the voltage. Okay? The total charge that an object has is equal to how much charge it can store, the ability to store charge, times the amount of electrostatic pressure, this potential difference, if you will. Okay, or I guess it would be the other way around on that phrase, but nevertheless. Okay, so that means that capacitance total times voltage total is equal to the capacitance of 1 times the voltage across that capacitor plus the capacitance of 2 times the voltage across that capacitor. Okay? But because it's in parallel, the voltage across that capacitor is the same as the total voltage. So I can cross these terms out. Okay? So I'm left with this equation where the total capacitance is equal to the capacitance of 1 plus the capacitance of 2 plus the capacitance of 3 plus the blah, 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 blah. Goes on and on and on and on. So when dealing with circuits that are in parallel, or capacitors that are in parallel, they are summative. The total capacitance is summative, not like resistors. So if you remember in resistors, it was the inverse that was summative. 1 over R is equal to 1 over R plus 1 over R plus 1 over R, etc., 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 when they're in parallel. In capacitors, it's the summative property. It's capacitor 1 plus capacitor 2 plus capacitor 3. That. But that should make sense in the way I've derived this equation, the way I've came up with this idea that capacitance is summative. Okay? Now we're going to talk about parallel, and we're going to find things are a little bit different.